session today will count as 2 hours CPD for you. The second session will be on next Thursday, exactly the same time. That's the 7th of March. So first of all, let's have a look at the aims and objectives of today's session. We are going to try and gain some sort of understanding about how this qualification is devised, to get some understanding of the content of the qualification if you haven't already looked at the full specification yet, to understand the assessment of the qualification and give some idea about how you can go about covering the content contained within it, to explore how to plan the course. I should have said at the beginning that this presentation has been devised on the basis that you are either fairly new to Pearson Edexcel or are considering swapping over from another awarding body and joining Pearson Edexcel. If you have already been teaching the qualification for quite some time, I still hope that there might be some information that would be useful to you contained within what I'm about to cover. Okay, so today's agenda. First of all, we'll have a look at welcome to Pearson. Perhaps I should give you a welcome to myself. As Ellie mentioned, my name is Cliff Curtis. You may be familiar with my name because I've been involved in training for quite some time. So you may have attended previous training sessions of mine, either online or face-to-face. But if you have purchased the Pearson student books that has been specifically written for the Pearson Edexcel International A-Level Chemistry, you may see my name on the front cover of that, because I co-authored both of the two books with Jason Murgatroyd. Okay, then we'll have a look at how the qualification is devised, the content of the qualification, some information about the assessment, and some information about planning the course. And then lastly, we'll have a look at the support that's available to you to help you to go about planning this particular course. So first of all, welcome to Pearson. We are the world's largest learning company, and as the UK's largest awarding organisation, we consider that we are best placed to provide qualifications for our international market, which are aligned to the British educational system. Our heritage stretches back to over 150 years. Today, we partner schools, universities and employers worldwide, and we offer world-class, globally recognised qualifications to over 3.5 million students a year. We're trusted and recognised qualifications partner to 6,500 schools, colleges and employers globally. We mark over 10 million exam scripts on behalf of the UK Department of Education each year. And lastly, we operate with 70 countries worldwide. So let's have a little look at how the qualification is devised. First of all, the structure. There are two separate qualifications available. The International AS, which is abbreviated IAS, and the International A-Level, abbreviated IAL. Both IAS and IAL are modular qualifications. There are 3 units at AS and a further 3 units at IA2. The qualification for IAS consists of 3 externally assessed units, units 1, 2 and 3. This can be awarded as a separate IS qualification, or students can use it to contribute 50% towards the IAL qualification. And in order to be able to get the IAL qualification, they have to sit 6 externally assessed units. The 3 units that I've already mentioned for IAS 1, 2, and 3, plus 3 IA2 units, units 4, 5, and 6. Students wishing to achieve the IAL, therefore, must complete all 6 units. That's absolutely crucial. So let's have a look at the contents. What do they have to cover in order to be able to get either the IAS qualification or the IAL qualification? So let's have a look at the overview of the specification for IAS first of all. As I mentioned, there are 3 units labeled Unit 1, Unit 2, and Unit 3. Unit 1 deals with most of the basic information that you would expect to be covered at the beginning of an A-level course, which of course students will need in order to be able to progress through the course. So things like formulae, equations, amount of substance, atomic structure, periodic table, bonding in structure, a little bit of introductory organic chemistry, dealing with alkanes and alkenes. Once you've computed Unit 1, well, you don't have to complete that in order to be able to move on to Unit 2. If you've got, if you're team teaching and you've got 2 teachers teaching the same class, you could possibly have someone starting Unit 2 at the same time that you start Unit 1. The more usual practice is for the 2 teachers to cover different topics in Unit 1 before you start Unit 2, but there's nothing to stop you going into Unit 2 immediately. And Unit 2 covers energetics, intermolecular forces, redox chemistry, groups 1, 2, and 7, introduction to kinetics and equilibria, and then a little bit more organic chemistry, alcohols, halogenoalkanes, and spectra. Unit 3, there's no specific teaching contents listed in the specification because Unit 3 tests their experimental skills. And I'll be talking a bit more about experimental skills later and also next week in the second presentation next Thursday. In Unit 3, students are expected to develop their experimental skills and a knowledge and understanding of experimental techniques by carrying out a range of practical experiments, investigations while they study Units 1 and 2. This unit will assess students' knowledge and understanding of the experimental procedures and techniques that were developed in Units 1 and 2. And I said more about the experimental skills later. The overview of the specification IAL, Units 4, 5, and 6. Unit 4, kinetics. The kinetics that are dealt with in IAS are largely qualitative, but the kinetics that you'll now deal with in Unit 4 will be considerably more mathematically based, as indeed will entropy and energetics and equilibria. The concept of equilibrium constants and their calculations will be dealt with at this level. Acid-base equilibria again will be mathematically based, so there will be calculations based on Ka and pKa, calculations of pH. So students will need to be mathematically competent. They will need to be able to work using logarithms. If they're not doing A-level maths, which a number of my students didn't do when I used to teach, and I used to get around this by simply telling the students which buttons on their calculators to press and the order in which they need to press them. So it's no big deal if they're not doing A-level maths. If they are doing A-level maths, of course, it's a big bonus for them. And then we deal with a bit more organic chemistry, carbonyls, carboxylic acids, and chirality. Unit 5, redox equilibria. This is where the concept of electropotentials are introduced, the use of electropotentials to predict feasibility of chemical reactions, the Arrhenius equation, which of course then now need to be able to utilize log to the base E, as well as log to the base 10, which they need for chemical equilibria and acid-base equilibria. Transition metals and their chemistry, organic chemistry, more organic chemistry cropping up now. We're getting to benzene chemistry, dealing with arenes, organic nitrogen compounds, amines, amides, amino acids and proteins, and finishing up, joining everything they've done with organic chemistry by looking at organic synthesis. Unit 6 is the second of the 2 units that assess experimental skills. And in Unit 6, students are expected to develop further the experimental skills and knowledge and understanding of experimental techniques they acquired in Units 1 and 2, the test for anions and cations, gases and organic functional groups, by carrying out a range of practical experiments and investigations while they study Units 4 and 5. This unit will assess students' knowledge and understanding of experimental techniques developed in Units 4 and 5, but they will also be tested, as mentioned in the previous paragraph, on the test for anions, cations, gases, and organic functional groups in Unit 6. So the students, both you and the students, need to be aware that questions will crop up on those particular topics, as well as what they will be studying, the practical work they'll be studying in Units 5 and 6. So you can see that 2 of the 6 units are actually assessing experimental skills, which puts quite a significant emphasis on carrying out practical work. And again, more about that later. Okay, so let's have a little look at the assessment of this particular qualification. How do we go about assessing each of these 6 units? There is Unit 1 for IAS, and you can see that it is an externally assessed paper, as indeed all of the units are. They're all externally assessed. They're all marked by qualified Pearson appointed examiners. It's a written examination which lasts 1 hour 30 minutes, and it's available in January, June and October. The first assessment was in January 2019, so there are plenty of past papers on the website. This particular paper carries a total number of marks of 80. The paper's in 2 sections. Section A is multiple choice. There will be 20 multiple choice questions, and section B is a mixture of short open questions, usually worth about 2 or 3 marks, open response questions that can get up to 6 marks, usually. Very rarely do we go beyond 6 marks. And there are calculation questions, which again can range from anything from 1 mark right up to usually a maximum of 6 marks or so. This paper will include a minimum of 18 marks that's targeted at level 2 or above. Level 2 is usually the mathematical standard will be a pass grade at GCSE. A level above level 2 will of course start to involve in more complicated techniques like rearranging chemical equations and then substituting to chemical equations, mathematical expressions, I should say, in order to be able to solve the problems. Students will be expected to apply their knowledge and understanding of experimental methods in familiar and unfamiliar situations. Level 2, Unit 2, is exactly the same in terms of its assessment, so there's no need for me to read through the whole of that. Again, it's an hour-and-a-half paper. There are 2 sections, multiple choice, 20 multiple choice, and a mixture of short, open response and calculations. This time there will be extended writing questions, which won't be present in Unit 1. And extended writing questions are marked in a particular way, and I will deal with that in a little bit more detail in the second section next week. This paper will contain questions that require information from the data booklet. And if you look at the specification on the website, that data booklet is contained within Appendix 9 within the specification. One of the things that I would recommend that you do for your students is encourage them to download that data booklet and print it off and have it in their folders so that they've got access to it and they get familiarity with it well before they start sitting the exam paper. Okay, and again, there will be a minimum of 18 marks targeted at mathematics at level 2 or above. Notice it's a minimum of 18 marks. Usually there's more than 18 marks, but there will be a minimum. Okay, and students will again be expected to apply their knowledge and understanding of experimental methods in familiar and unfamiliar context. And this paper may contain some synoptic questions which require knowledge and understanding of Unit 1. And that's one of the things that sometimes both teachers and students are not aware of. So you need to be aware of it, and you certainly need to make your students aware that there may be a synoptic element to Unit 2. Unit 3 is the assessment of practical skills in chemistry, a 1 hour, 20-minute paper, again available in January, June, and October. This paper is worth 50 marks. And when you apply the uniform mark scheme, the total percentage for IAS for the 3 papers works out at 40% for Unit 1, 40% for Unit 2, and 20% for Unit 3. And because, of course, the IAS together counts 50% towards the IAL, then of course those percentages are halved as a contribution towards the overall international A-level qualification. So it goes down to 20, 20, and 10. With regard to the content overview for Unit 3, students are expected to develop their experimental skills and knowledge and understanding of the experimental techniques carried out in a range of experiments and investigations while they study Units 1 and 2. And this unit will assess the students' knowledge and understanding of these experimental techniques that were developed when you're teaching these 2 units. The paper will consist of short, open response and calculation questions. There are no multiple choice questions on Unit 3. This paper will include a minimum of 6 marks targeted at maths at level 2 or above. And they will be expected to apply their knowledge and understanding of practical skills in both familiar and unfamiliar situations. I'll talk a lot more in detail about the familiar situations later with regard to the core practicals that are listed in the specification and what we mean by unfamiliar situations. Okay, IA2, which is Units 4, 5, and 6. Again, I don't think I need to go through every single detail here, but just note that the papers are very slightly longer for Units 4 and 5. They're 1 hour 45 minutes, and they carry a total of 90 marks for these. Again, in both Units 4 and Unit 5, there are 20 multiple choice questions, and this time, both of these 2 theory papers will contain not only short, open response calculations, both of the papers this time will contain extended writing. And there will be, in both of these, a 3rd section called Section C, which will be a question involving the application of data supplied. So data will be supplied and the students will be expected to answer the question using the data that's supplied in the question, or it could in fact be an extended calculation. Again, on both of these 2 papers, there will be questions that will require information from the data booklet. And this time, there will be a minimum of 22 marks on Unit 4 for maths and a minimum of 18 marks on Unit 5 paper targeted at maths. And again, in both of these two papers, the students will be expected to apply their knowledge and understanding of experimental methods in familiar and unfamiliar contexts. And the paper may contain some synoptic questions that require the knowledge of units 1 and 2. That's for Unit 4. And have a look at the bottom of Unit 5, the very last bullet point. This paper may contain some synoptic questions which require knowledge and understanding from units 1, 2, and 4. So please, very, very important to make your students aware of that when they are preparing for sitting units 4 and 5. Unit 6 is back to the practical skills. And this is a 1 hour, 20-minute paper worth 50 marks. And when you take the uniform mark scheme into account, then you can see that Unit 4 and Unit 5 count 20% towards the total AL, and Unit 6 counts 10% towards the total IAL. To get the total 100%, of course, you need the 3 units from IAS. Okay, so I hope that's fairly clear. All of that information, again, is in the specification that you can download from the website. So I would very strongly recommend that after this particular session, if you haven't looked at this particular area of the specification in detail, that you have a very close look at it so you can be in a good position to advise your students when it comes to their revision for sitting the papers. The unit results, there's no change in the uniform mark scale from the previous qualification if you were involved in teaching the previous qualification. Units 1, 2, 4, and 5 have a maximum of 120 uniform marks, and units 3 and 6 have a maximum of 60 uniform marks, which of course is shown by the percentages that I showed on the previous slides. How the uniform marks are calculated from the raw score marks, there is information on the website to show you how those uniform marks are calculated if you're particularly interested. If you can't find it on the website, then just simply type into your search engine, whichever one you use, Google or whatever, just type in how to calculate uniform marks from raw marks, Pearson Edexcel, and you should get us a results that will take you to a link to how the uniform marks are calculated if you're particularly interested in that. The grades are awarded on uniform marks and not on raw score marks. So in order to be able to get a grade A on units 1, 2, 4, and 5, they need to be able to get 96 uniform marks out of the 120. And on units 3 and 6, to get a grade A, they need to get 48 uniform marks out of the 60 uniform marks available. And the uniform marks are scaled down for the awarding of grades A, B, C, D, and E. And they're shown in the slides in front of you. So IAS is a total of 300 uniform marks. IAL is a total of 600 uniform marks. And in order to be able to get a grade A overall at advanced subsidiary, they need to be able to get 240 uniform marks out of 300. And for IAL, they need to get 480 uniform marks out of the 600. Students that fall in the mark range 0 to 239 for IAL will be classified as U, and for IAS, students that fall into the range of 0 to 119 will be classified as U. Okay, so 120 uniform marks to be able to get an E at IAS and 240 to be able to get an E at IAL, and then scaled up to the grades as shown there. Okay, now if you can look at your specification at the same time that you're looking at my screen, in other words, you can bring up the specification at this particular point, then you should be able to find out which particular specification point the following question is assessing. Now, the reason I've set you this little task is because when the examiners are writing their exam papers, they need to be able to, they are asked by the chair of examiners to set questions on specific specification points. The aim over the course of 3 to 4 year session is for the exam papers to be written to cover all of the specification points over that particular period of time. Now, if you've managed to get the specification up at the moment, the clue is that this particular specification point is in topic 3, and it is under, obviously, metallic bonding. So if you can find that, have a look. There's no need to put your answer into the chat box here. Just see if you can find out which particular specification point that is. It's under the metallic bonding in topic 3. I'll give you a little while just to have a look to see if you can find it, and then I'll tell you which one it is. But if you've managed to find it, it is 3.22, and it's the one that says students should be able to use the models in 320 and 321 to interpret simple properties of metals, including electrical conductivity and high melting temperature. The model that's specified in the specification is that metals consist of a lattice of metal cations surrounded by delocalized electrons. I'm well aware that there are 2 theories of the nature of metallic bonding. Another one, which I happen to prefer, is that metallic bonding, the metallic structure consists of atoms surrounded by delocalized electrons, and the metallic bonding is the electrostatic force of attraction between the nuclei of those atoms and the delocalized electrons. But that's not the one that is on the specification. The specification says cation surrounded by delocalized electrons, and that the metallic bonding is the electrostatic force of attraction between those cations and the delocalized electrons. So that is the one, obviously, that you must teach to your students. Okay, where does this free electrons come from? Has someone put this? Okay. There's, good. You've removed that out. Okay. Here is a question that assesses specification statement 910. Which equilibrium shifts to the right-hand side when the pressure of the equilibrium decreases at constant temperature? This is the specification point that says students should be able to predict and justify the qualitative effects of changes of temperature, pressure, and concentration on the position of equilibrium in a homogeneous system. This is a multiple choice question, so they simply have to try and answer the question by looking at the number of moles of gas on both the left and the right hand side. Okay, if this had happened to have been an open response question or a short response question, and they were asked to state what would happen to the position of equilibrium, it's probably well worth my while mentioning at this stage that there is no mention on the specification of Le Chatelier's principle, and any reference to Le Chatelier's principle in an answer never gains any credit. That doesn't mean you don't have to teach Le Chatelier's principle if you think it is worthwhile doing so. I happen to think it is a complete and utter waste of time to use Le Chatelier's principle, but that is my own personal preference. There's a huge amount of research that is being done to indicate that using Le Chatelier's principle leads to not a very full understanding of equilibrium concepts, but I haven't got time at the moment to go into that. But I have written in the international GCSE section of the specification. If you are at all interested, look on the website at the international GCSE qualification and look under teaching and learning resources, and you'll find a topic guide that I've written on chemical equilibrium. And I've got in there all my reasoning as to why I think Le Chatelier's principle is not worthwhile doing, and an alternative way of teaching the effects of qualitative changes on position of equilibrium. Anyway, I'll leave that up to you to decide whether that's something that you would like to pursue. Okay. Activity 3. Again, no need to put down the information here in the chat box, just something for you to think about. And I'll give you a couple of minutes to have a think about it. There is a question that was on a recent paper. Okay. The compound POCl3 has a simple molecular structure. Complete the dot and cross diagram and explain the shape of this molecule using the electron pair repulsion theory. So my question is just simply have a think about what are the essential points to include when you're answering this particular question. Okay. And then I'll give you the reason why I'm asking you to think about the essential points before you actually start answering the question. Okay, so just have a minute or two to have a think about the essential points. Right, first of all, let me give you the reasoning behind my question. What are the essential points to include in answering the following question? 2 questions. Students often go in to answering questions without giving any thought to what they're going to put down in the question. They just go straight in and answer a question, then suddenly realize on occasions, I'm sure you've seen this yourself, that students get involved in this and they suddenly realize, hang on a moment, I'm on the wrong track here. They have to cross out exactly what they've written and then start over again. So I always try and encourage my students when they're approaching a question to have a think about what are the essential points to include before they start putting pen to paper. And this particular instance, where's all that marking come from? Someone has put some marking. Can we get rid of that, please? All that red marking. Okay. I don't know where that's come from. I'm hoping that's lovely. Thank you very much. Yeah, if you could avoid doing that, that would be very helpful. Thank you. Okay, right. So the first thing I would think is that they need to put in the bonding pairs. They need to put in the non-bonding pairs on both O and Cl. Okay. They then need, of course, to state the shape of the molecule. They then need to put in the explanation for the shape, which are the regions of bonding electrons repel one another to adopt positions of minimum repulsion. So that is the sort of thought process that I would like a student to go through before they start answering the question. Okay, so it's just a thought. It may be something that you think might be worthwhile passing over to your students in order to get them so that they don't go down this route of starting the question, going along completely the wrong idea, having to cross out and then start writing again. It's just a thought. I'll leave that one with you. Okay, right, so here we go. Another aspect of writing examination papers that the exam paper writers have to take into account is the different assessment objectives that are listed in the specification. And there are 3 of them that are listed, labeled AO1, AO2, and AO3. AO1 is about demonstrating knowledge and understanding of science, and that's pretty basic understanding of science. So it would be simply things that are listed on the specification. The knowledge would be what is the shape of the water molecule and explain the shape of the water molecule. And because the shape of the water molecule is listed on the specification, that would be considered to be basic understanding. AO2 is an application of knowledge and understanding in both familiar and unfamiliar contexts. So the application, let's go down the theme of shapes of molecules. If they were then asked to explain the shape of the molecule of hydrogen sulfide, that is not listed on the specification, so that would be AO2A. So that's an example of that, of the application knowledge and understanding. They have to apply their knowledge of the shape of a water molecule to the shape of the hydrogen sulfide molecule. Analysis and evaluation of scientific information to make judgments and conclusions is classified as AO2B. So AO2 is split into 2 separate ones. So here is where they have to look at scientific information that has been listed in the question itself, and they then have to make judgments and reach conclusions, having analysed and evaluated the scientific information that's actually been presented in the question. And AO3 is all about experimental skills in science, including analysis and evaluation of data and methods. AO3 will only be assessed in units 3 and 6. That doesn't mean that there are no questions set in units 1 and 2 on experimental skills, but they are based on a theoretical basis rather than on the practical, the skills that are being developed as a result of carrying out the experiments. Anyway, a lot more about assessment objectives and their application next week in the 2nd session on March the 7th. Okay, so hopefully that's given you a little bit of an understanding. I will be dealing a bit more about those assessment objectives next week and how they're utilised and applied by the examiners when they are devising their examination papers, because they have to keep to a certain percentage of questions of both AO1, AO2A, AO2B, and AO3. If you're confused at the moment about the difference between AO2A and AO2B, hopefully what I do next week, next Thursday, will help alleviate that confusion. Okay, so let's have a look about the plan in the course. There is, of course, one key document that you need to deliver this particular course. And of course, it's pretty obvious. It is the specification. That is the key document that is required. Why do we need that? Well, because, of course, the specification is the main document that you need, because it outlines the aims of the course, the content that you cover, and it's got all of the information you need about assessing your students. So it's got a lot more information than I've been able to deal with today. And it's even got more information about the assessment of the course that I will be able to include in the presentation next week, next Thursday. So, and of course, you can find it on our website. You simply go to Pearson qualifications. If you haven't got that bookmarked yet, I would suggest that you type into your search engine Pearson qualifications and bring up the relevant page and bookmark it, because it's something I think you'll need to refer to on many occasions. Okay, so how do you go about making sure you cover all of the content? Well, the first thing is you need to look at every single specification statement on the specification and make sure that you cover every single one by the time you finish the course. It's as simple as that. Okay. How do you go about making sure? Well, perhaps you might like to consider producing schemes of work so that that will cover everything that you're going to do during the course of your teaching for the first year for IAS and the second year for IA2. And then you can go through the whole of those schemes of work and check within them that you've got every single specification point listed and tick them off one by one. And that will make sure, of course, that you know that you are covering all of that particular work. More about schemes of work in a moment and what perhaps it might be useful to put into the schemes of work other than just a list of specification points to cover. Okay, and the second thing, of course, is once you've got your scheme of work, it may well be useful for you to be able to create individual lesson plans for every lesson that you're going to teach. If you are a very, very experienced teacher and been teaching for a number of years, I mean, by the time I got to the end of my teaching career, I had been teaching for 38 years. And I personally didn't need to have lesson plans in front of me. If you are fairly new to teaching, of course, I would strongly recommend that you do produce some lesson plans. And if you're not familiar with some content, what should be put into lesson plans, I've got some ideas which I will share with you in a moment. Now, for those of you who are familiar with already producing lesson plans, I hope you'll bear with me when I go through this, because, of course, I did mention at the beginning of the session that this session is targeted at people who are new to Pearson Edexcel and perhaps could even be fairly new to teaching. Please bear with me if I'm teaching you something that you already know. There is a scheme of work on the website, which you can make use of. You don't have to follow this scheme of work if it doesn't suit your particular style of presentation of scheme of work, or indeed your school or centre may have a scheme of work that you have a format for a scheme of work that you have to follow. But what you can do is you can look at this scheme of work and then you can pick out what is useful for it, and you can incorporate it into your own scheme of work, or indeed the format that your centre, your school insists on you following. And you can see that in the left, the second column there's topic area and aims and learning outcomes that you can list there. And topic, the first week, they're suggesting, this scheme of work is suggesting that you perhaps start with amount of substance, and you list all the learning outcomes in this scheme of work. And then the third column there has got exemplar classroom activities, teaching points, and suggested resources. You will have possibly your own exemplar classroom activities and teaching points and suggesting teaching resources. What you can do, of course, is you can look at these and see whether or not any of these are worthwhile adding to or incorporating into your already existing scheme of work. So it's just some more suggestions. And then the very last column has got into integrated transferable skills that are listed in the specification. The transferable skills are listed there. Transferable skills, of course, are very important for students to take with them when they go into further education, or indeed they may go straight from A-level into the world of work. Okay, so as I said, let's talk a little bit about possible components of a lesson plan. These are just some ideas that I've got, and you may have your own ideas, which is absolutely fine. I'm not trying to pigeonhole you into following my ideas, but I'll just go through a few of mine. If I was creating a lesson plan, I would certainly have a title of the lesson down as my at the very, very top of that particular lesson plan. I would also have an idea of the time required to complete that particular lesson, which of course has got to fit into the scheduled timetable that you have in your establishment. I would have a list of required materials in that particular lesson plan. That may include things like any worksheets that I'm going to hand out to them during the course of the lesson. It may also have a list of any chemicals or apparatus that are required, which I can then pass on to my laboratory technician if you happen to be lucky enough to have one, so that your laboratory technician is able to get out all the chemicals and apparatus in advance of the lesson and have it ready for you. I would then have a list of objectives within the lesson plan. In other words, I would want listed what I expect the student to be able to know by the end of the lesson. If I don't know what I expect them to know by the end of the lesson, then of course there's no way of me testing what I want them to know, would expect them to know. So if I don't know what I expect them to know, how can I test what I expect them to know? So I think a list of objectives is absolutely crucial, but that's my own personal opinion. Okay. I would then have a lead into the lesson rather than go straight in to the nitty-gritty of the lesson, to try and focus the students on the lesson skills or concepts. This could include showing pictures and models. It could include asking leading questions, or it could involve reviewing previous lessons. I'm sure very well, you are all very well aware that chemistry is based on scaffolding, a scaffolding approach. Students do need to know a previous knowledge in order to be able to access topics later on in the teaching. And so sometimes it's well worthwhile just having a quick review of a previous lesson when you know that the content of that previous lesson is going to be very important to the student's understanding of what you're about to teach them. It could be false economy to assume that the students have a very good understanding of what you taught them 2 or 3 weeks ago, and particularly if it happened to be 2 or 3 months ago. So it may well be worthwhile having a quick revision of what's gone on in the previous lesson when you know that that understanding is going to be fundamental to understanding of what you're about to teach them. Then I think you need to have details. I personally would have details of an instructional component that describes the sequence of events that make up this particular lesson. So this is your input, exactly how you're going to go about teaching this particular topic. And where appropriate, guided practice by the students to consolidate new skills and ideas. Now, this guided practice could be in the form of you simply asking them questions. So perhaps those questions could be listed. If you have no questions that you are going to ask before you even start the lesson, then it might be a good idea to list those questions in your lesson plan so that you don't forget to ask them. Guided practice could be in form of very, very simple questions, which you may have on pieces of paper, or if you are projecting onto a whiteboard, or you're using an interactive whiteboard, they could be questions that you then project onto the whiteboard and get them to answer by raising their hands. So they could be doing this individually, or perhaps you could get them to work in groups to get the answers to these particular questions if they happen to be slightly require slightly longer responses, and then getting a spokesperson from the group to answer the questions, but something that gives them practice to consolidate what you're doing. And I think it's probably worthwhile doing this during the course of the lesson and not just waiting to the end of the lesson. So try to consolidate the new skills bit by bit and build up their confidence as you go through the lesson. Okay. And then perhaps towards the end of the lesson, some independent practice that allows the students to extend their skills and knowledge on their own. If you've got time during the lesson, then you could hand this out at the end of the lesson. But if you haven't, then you could hand it out for them to do during the lesson. But if you haven't, you could hand this out as their homework. So try and get some form of question that will be perhaps in an unfamiliar context to the familiar context that you've developed during the lesson. This, of course, is important because, as I've mentioned earlier, questions will be set on both familiar and unfamiliar concepts in both the theory papers and the experimental skills papers, units 3 and 6. So that could be done for homework. Okay. Then, of course, you could have a summary where you wrap up the discussion and you answer any further questions that the students happen to have. If you are doing a practical, it is essential, of course, I believe, to have a risk assessment where you have listed the lesson's risks and you have listed the steps to minimize them. They're documented. This really is to cover yourself, because if something goes wrong during the experiment and there happens to be an accident, and that accident happens to happen because the students have not followed the steps taken to minimize the risks, then of course it covers you. Because if you have got these listed and you read these out to the students before they start the experiment, then they of course know what they should be doing. And if they don't follow that, then you've got documented evidence that you did in fact tell the students that this is required. Of course, that is only one aspect of it. You do want your students to work safely in order to be able to safeguard themselves. But there is another aspect to this, and that is in units 3 and 6, questions will be asked on the risks involved in practical procedures. And this risk could be involved in a procedure itself, or it could be involved in using a particular chemical. So, for example, the question could be set: what is the risk involved in using concentrated sulfuric acid, and how would you minimize the effect of this particular risk? And of course, the risk is that concentrated sulfuric acid is corrosive to the skin, and to minimize the effect of that, you wear gloves. protective gloves. So questions like that will be asked. Another one could be, what is the risk involved in an experiment that produces chlorine gas? And of course, on that case, it is that chlorine gas is poisonous. How do you minimize the risk of that? You carry out the experiment in the fume cupboard. So questions like that will be asked. So therefore, it's very important that you have these discussions with your students. If you've got these listed in your lesson plans, then you will make sure that you cover those. And lastly, I'm a great believer in having an analysis component at the end, where you, as the teacher, reflects on how well the lesson has actually gone. Has it actually worked well? Were there aspects where it didn't work quite as well as you thought it should? So are there any ways in which perhaps I could go about improving this? Because the students didn't seem to be grasping what I wanted them to grasp. Was it their fault? Was it my fault? Sometimes in the past, it has been my fault. And there were times when I couldn't work out. I couldn't come up with an answer. So I went back to more experienced. When I was an inexperienced teacher, I would go back to the more experienced teachers within my department and say, I'm sorry, but I couldn't quite get over this particular concept. Have you any ideas about how I could perhaps improve my method of presentation of this? And I did get some very, very good ideas from the more experienced teachers within my department. By the time I'd been teaching for 38 years, of course, I had most of the things pretty well sewn up, but I still managed to be able to get excellent ideas during the course of the departmental meetings I had from my members of my department. I never ever thought that for one moment that just because I'd been teaching over 30 years that there was nothing for me to learn. I'm always a great believer that one is always learning. And even though I've now been retired for nearly 13 years, I still believe I'm always learning. And it's one of the reasons why I really love doing teacher training, particularly face-to-face training, where I can have discussions with teachers and get other teachers' opinions. And I'm still learning from them as much as I hope perhaps some of you do get the opportunity to learn from me and from my experience. Okay, a little bit more about the practicals involved in the specification. I have emphasized, of course, that practical work is very, very important. And to emphasize this within the specification, there are 16 core practicals listed, 8 at AS and 8 at A2. It is strongly recommended that students complete these core practicals in order to develop the necessary skills to enable them to be able to answer the questions that will be set in Units 3 and Unit 6. In an ideal world, it would be lovely if they carried out each core practical individually, but of course, in a practical, in the normal situation, they usually have to work in groups of 2, hopefully no more than groups of 3, in which they can perhaps share doing the experiment themselves. But it's very, very useful for them to actually see some hands-on experience of doing all of these core practicals. However, if it is totally impossible for you to be able to do a particular core practical because you cannot get the required chemicals, then you can substitute a similar core practical with chemicals that you can get the hold of that develop exactly the same skills. So, for example, if an experiment involves using a particular weak organic acid as for a standard solution for a titration, and you can't get that particular organic acid, then substitute another organic acid. And that's perfectly acceptable, of course. So you don't have to use the exact same chemicals that are listed in the core practical, as long as the practical you do covers exactly the same skills. Secondly, if you can't get hold of any chemicals at all to carry out a particular core practical, or you cannot get the apparatus to carry out the core practical in sufficient supply to be able to do class practical, then at least do a demonstration. And if that is impossible, then try and find a suitable video clip from the website, perhaps looking at the Royal Society of Chemistry website, because they do have quite a lot of practicals on there, a large number of which are actually targeted at Pearson Edexcel core practicals. So the Royal Society of Chemistry website, and just simply type in experimental practicals, and into the search engine, and you may well find, you should easily find those particular practicals. YouTube, do be careful of YouTube, because there's some very, very dubious practices I've seen on YouTube, with experiments not being carried out in a safe way. So do make sure that you're very, very careful about what YouTube videos you show. Some of them I would never show to my students in a million years. Okay. There are a lot of other suggested practicals in the specification. These, of course, are totally optional. You can substitute other practicals that you know work particularly well, that you like doing. So add or substitute your own practicals too. As a rule, I would say do as many practical work as you possibly can within the time allocated to you. The more you do, better. And there's one other thing that I would very strongly stress, and that is that just don't leave them to follow the experimental recipe that you supply for them, and just leave it at that. It's very, very important that the students not only have an appreciation of what is required, what they have to do, but why the practical is carried out, why the method is carried out in that particular way. Let me give you an example of why this is important. If a question is set, how do you carry out a recrystallization, then a lot of students will learn that description off by heart, and even some of the weaker candidates will be able to score very, very well in a question that simply says, how do you carry out a recrystallization? But when you start asking them, why is the impure substance dissolved in the minimum amount of hot solvent at the beginning, then the number of students that can get that answer correct drops significantly. And this could be because perhaps they haven't been involved in a discussion over why the recrystallization process is carried out in the way in which it is carried out. Start asking them in which point in the procedure are the soluble impurities in the substance removed, and at which stage in the procedure are the insoluble impurities removed. Ask them, why does the substance that you're trying to obtain crystallize out when the hot saturated solution is cooled? Then you find that a lot of students have absolutely no idea whatsoever as to why this happens. So a discussion, the more discussion you can have about why the practical is carried out in this particular way, the better. So as I said, students will be assessed on their practical skills in units 3 and 6. They will include testing the skills of students in familiar and unfamiliar applications. So the familiar applications, of course, are the core practicals. Unfamiliar applications are where the exam will have a question on a practical procedure that the students probably have not met before, but will be testing the skills that have been developed in carrying out the core practicals, which is another reason, of course, why the core practicals need to be carried out. They will be asked about planning, including risk management and selection of application, and the reasons why they need to carry out, why they need to select this particular apparatus. So they have to have a very, very good understanding of why particular apparatus is used. So, for example, if you are adding excess acid to calcium carbonate in order to follow the rate of the reaction between hydrochloric acid and calcium carbonate, and what you are studying is the effect of surface area of the marble chips on the rate of the reaction, why is it not necessary to measure out the hydrochloric acid using a burette? Why is it just okay to use a measuring cylinder? Why do you not need to go to a more precise measurement? And the answer, of course, is, well, the acid is in excess anyway, so why do you need to measure it precisely? So there are some times when precise measurements are not needed. In the core practicals, sometimes there are procedural errors involved. So, for example, when you are adding the acid to the hydrochloric acid, if you are collecting the gas using either a gas syringe or over water, then if you add the acid to the marble chips in a conical flask and then put in the rubber bung afterwards, then of course some of the gas will be lost between adding the acid and putting the rubber bung in. So students need to be aware of procedural errors, and then of course methods by which they could minimize those procedural errors. And we are looking for procedural errors here. We're not looking for answers like, oh, well, the student didn't read the burette properly because there was a parallax error because they didn't get their eye level with the meniscus. That's not what we're looking for. We're looking for errors in the procedure, not what the student may well have done incorrectly. So discussions like that are also very important. There will be other questions covering data handling, including the use of significant figures, processing data, and plotting graphs. And there are a lot of information available in the support material, which I'll be coming to later when I deal with support in a moment, in a guide that's called the Practical Guide, Teacher's Practical Guide. Unit 3, as I said, is a written practical exam, and it covers the skills and techniques developed in units 1 and 2. And remember that there are 8 core practicals, and they have to apply their knowledge to new practical situations. This is why they need to develop their practical skills by completing a range of different practicals that require a variety of different chemical techniques. So I emphasize once again, the more practical work you can do and the more different techniques you can cover, the better. Okay, and as I said, suggested practicals are included at the end of each topic, but they are optional. The points in Unit 3 also apply to Unit 6, but this time, of course, they need to carry out, they need to develop experimental skills with the practicals they study in Units 5, 4, and 5. So questions may be asked on recall or interpret the observations relating to tests and gases in Units 1 and 2. This, of course, is applicable not only to Unit 3, but also to Unit 6. And they may need to recall, I don't know why that's cropped up twice. Recall or interpret observations relating to tests for organic functional groups in Units 1 and 2. This applies not only to Unit 3, but also to Unit 6. They also need to be able to manipulate data and comment on experimental methods and techniques for a range of experiments involving measurements in Units 1 and 2, including molar mass calculations and titrations, thermochemical investigations, and simple kinetic experiments. So all of this lot is need to be covered. So you can see that Pearsons are taking experimental skills very, very seriously indeed. And therefore, my strong recommendation is that you do carry out as much experimental work and discussion of experimental work and analysis and evaluation of experimental data as you possibly can throughout the whole of the course. Okay. And they need to be able to comment on experimental methods and techniques in the preparation of inorganic or organic compounds in units 1 and 2. And that applies to both units 3 and unit 6. So there is a synoptic element to unit 6. I mentioned that earlier, and I re-emphasize that now for both you and for your students to be aware of, that there is a synoptic element in unit 6. Okay, so what support is available? It all sounds pretty daunting so far, but we have got an enormous amount of support available for you in both free online resources and also paid for resources, which I will now share with you. The online support is that there are teaching and learning materials available on the Pearson qualification website. You simply go into Pearson qualifications, A levels, C for chemistry, scroll down, and you need to scroll down right down, quite a way down, and click on international advanced level, click on chemistry again, and then you'll come up with a screen which has got one of the bullet points will be teaching and learning materials. Another bullet point will be past papers, mark scheme and examiners reports. Another one will be teachers resource packs. And the paid for resources are student books and lab books. Okay, that is the teaching and learning materials. You can see that you've got specification and sample assessment materials, exam materials, which will have all of the past papers in it, and teaching and learning materials. And then if you click on that particular tab, then you will have a lot of information. I've just shown the first one, which is the data booklet. There's a huge amount of information of teaching and learning materials, some of which I will mention just a moment. You've got exemplar material, you've got a getting starting guide, you've got a teacher mathematical support, you've got a teacher practical guide, there's a transition guide, there's past training content, which you can look at for some of the training that's taken place before today's training. There's the scheme of work that I mentioned earlier. There's a topic guide on energetics, energy and entropy. That has been written by George Facer, a name that some of you who've been teaching for a while may well recognize because he's produced a lot of resource material for Pearson Edexcel, and including student books and also other resource material. Okay. George was the chair of examiners many, many years ago. He was the first chair of examiners that I worked for when I used to do A-level marking for Pearson's, and probably one of the most gifted teachers that I've ever come across. I learned a lot from him. Sadly, he passed away fairly recently, a great loss to the chemical world. But that topic guide is well worth reading. Okay, and there's also another topic guide called Instrumental Analysis. That one has been written by a lecturer at Southampton University called David Reed, and we got him to write that because, of course, there were some extra topics put into the current specification that weren't in the previous one. For example, carbon-13 NMR is included now, which wasn't in the previous specification. So we thought it might be worthwhile getting a topic guide on that. That topic guide is well worth reading from David, and I very strongly recommend that you have a look at that, okay? Just talk a little bit about each of those if I can. The exemplar material, it's got some student answers from previous exam sessions. They've been marked by a senior examiner, and there's some commentaries that have been added. It gives you an opportunity to see some good practice and see where students often make mistakes, which could then influence the way in which you approach the various topics. The Getting Starting Guide provides an overview to this particular specification, gives you some information about the content in the assessment, and gives you a better understanding of what these mean for you and your students. The math support, math skills obviously are not new to A-level chemistry, but the new international advanced levels have a requirement to ensure compatibility between GCE A-level, that's the UK specification, for these skills to be routinely tested. This means for both international advanced supplementary, IAS, and for IAL, at least 20% of the marks on the exam papers will assess math skills of the relevant chemistry. In order to develop their skills, knowledge and understanding, students need to have been taught and acquired mathematical competence in the appropriate areas of maths relevant to chemistry. And you will find all of those skills, knowledge and understanding in that mathematics support. So I very strongly recommend that you have a read of that. The practical guide, a very good opportunity. This will give you a lot of insight into how to approach the teaching of practicals, how to draw graphs, techniques of drawing graphs, and a lot of other detail about approaching practical chemistry. So an excellent guide I would suggest you read. The transition guide, well, research has shown that teachers often fall into the trap of going over work that's already been covered extensively in international GCSE. This could be because of a feeling that during the summer break, students have forgotten what they've been taught, or if they've come from different centres, you've got some degree of uncertainty about the standards that they've so far reached. This is where you could lose valuable teaching time and later find yourself rushed to complete the international A-level content. To help you with planning and teaching your first few A-level lessons and to save you time, we have worked with practicing teachers and examiners to develop these valuable resourced transition materials. These will help you reinforce the key concepts from international GCSE and A-level and guide your students' progression. So have a look at the transition guide and see what is in it that you think you might be able to make use of. One of the things that I probably would do if I was still teaching would be to take certain aspects of that transition guide, particularly the baseline tests, and give them to the students to do over the summer break so that they can come in at the beginning of the A-level course. Hopefully, having done those baseline tests, you could go over them and test to find out exactly what they do and don't know, and take appropriate action. The scheme of work, I've already mentioned the scheme of work in detail. So take that on either face value or use it to modify your own particular schemes of work. And I've already talked about the two topic guides. Okay, so that's the exemplar material sheet. As I said, there are exemplars of student work and commentaries. Unfortunately, it's only available for IAS. There seems to have been no move to do a similar document for IAL, but at least you've got some marked exemplars and teacher commentaries for IAS. Okay, there's the Getting Starting Guide for you to recognize. Okay, I've already discussed about that. I'll give you a chance just to read that. There's the teacher of mathematics, so you can recognize that particular document, okay? And it covers mole calculations, enthalpy changes, reaction rates, equilibrium calculations, acid-base equilibrium pH calculations, and electropotential calculations. So a wealth of useful information there. So again, I very strongly recommend that you download and read that document. The practical guide, it will support you and your students through all the elements of practical work in this particular specification. It will explain how the new requirements for practical skills can be developed throughout the course using both core practicals and other specification content. So again, I can't emphasize too strongly how useful I think it would be for you to download that document and find time to read through it. Okay, and I've mentioned the transition guide. It includes a mapping of Edexcel International GCSE to this particular specification. It's got baseline assessments, which I strongly suggest you give to your students, perhaps to work at over the summer holidays if you know they're going to be taking A-level chemistry. They've got summary sheets, they've got student worksheets, they've got some practice questions, okay? The teacher version also includes answers to the assessments, the worksheets, and the exam practice. There is a student version which you could encourage your students to download and perhaps print off for themselves or just work from on their own particular PC or laptop. Okay, I've already mentioned the scheme of work. Okay, it includes recommended teaching time, the topics, classroom activities, and objectives for students at the end, areas for transferable skills. And I showed you a sample of that much earlier during this presentation. So again, have a look at that scheme of work and use it as you feel appropriate, okay? And I mentioned the topic guide, some ideas of how to address common misconceptions in both new and previously included content, possible teaching sequences for key specific points where there's a new or challenging content. I think we could all agree that energetics, particularly entropy, is probably one of the most difficult concepts to teach in A-level chemistry. And so using George's experience here may well prove very, very helpful for you. So I very strongly, again, recommend downloading this and having a read of it. There are some worked examples that you could use to support students in developing their understanding, which you could then add and supplement to your own. And then you've got the instrumental guide, some ideas on how to address misconceptions, possible teaching sequences, again, to deal with key specification points, particularly where there's new or challenging content like carbon-13 NMR, and some worked examples that students use to support their students in developing their problem-solving skills, okay? And there are some links to external websites that can be used to further students' understanding. Okay, and I mentioned at the beginning that there are some student workbooks, and you can see my name associated with that. Okay, I and Jason Murgatroyd were the co-authors of this. David Scott did the work, I've forgotten what they're called. The let me have a look at one of the books. It's the bit that says the extension work. I've forgotten what they're called. Right at the very end of the each particular chapter, there's it's almost like what can I call it? There's a section. Just hang on a second. Let me get the book. That's it. Apologies for the delay there. It's the sections that are called Thinking Bigger. That was David Scott's contribution to the book. So all of the theory has been covered by myself and Jason Murgatroyd. I did the bulk of the I did all of the physical chemistry and a few other topics. Jason did the organic chemistry, except for the extra topics in organic chemistry that are on the A-level specification. They're not on the UK specification. I added those at a later date, okay? So those books are available. I will say that it is not a requirement for you to use these books in order to deliver the Pearson Edexcel qualification, okay? You don't have to use these particular books. I'd like you to use them, of course, but you don't have to. However, I would strongly recommend you get at least an inspection copy of these. They usually come free of charge, so that you can have a look through them and see the way in which the topics are tackled. One of the useful reasons for having at least an inspection copy of these, of course, is that the chair of examiners and the chief examiner both have these copies of these books, and they do look at them when they are looking at the exam paper questions to see how the topics are covered in these books, and therefore make sure that their mark schemes reflect the way in which the topics are covered in these two particular books. But as I said, you do not have to use these books with your students. You can use any student books that you like. Okay, it's not essential to use these. Okay, I did mention earlier that there's also a lab book, okay, which you can buy. You may find the lab book works out cheaper than downloading and printing all of the worksheets for all of the core practicals for your students, depending on your photocopying budget. If photocopying your school is free of charge, then of course the lab books will work out more expensive. But have a look at that, see what it costs. One of the advantages, of course, of having the lab book is that they've got all of their practical work in one place. And one of the problems I always found with my students, particularly those that weren't very good at organizing themselves, is that they did not manage to be able to keep their practical work in the appropriate place in their folders. It was all over the place. And when they came to do their revision, they never really looked at the practical work associated with that theory, and therefore didn't prepare themselves properly for answering the experimental questions that cropped up in the theory papers, Unit 1, Unit 2, Unit 4 and Unit 5. Having it all in the lab book and then pointing out to the students that when they are revising for their theory papers, that they need to look at the associated practical work just might help. But again, it's a decision that you need to make for your own particular centre. Okay, well, that covers all of the support that I'm going to talk about today. Okay, but there is one more very, very important resource, and that is the subject advisor that is based in the UK, and that's Irene. Irene is an excellent source of information. So if you have any questions at all about this particular qualification, including the exam papers themselves or the mark schemes, you don't understand why a particular answer is in the mark scheme, or you don't understand why an answer that you thought should be in the mark scheme isn't in the mark scheme, then just simply drop Irene an email, and she will get in touch with the appropriate principal examiner and get an answer back to you. And that will help you to further understand the way in which the exams are marked. So Irene is the port of call. Any doubts you have about the method of assessment and preparing your students, Any concerns you have whatsoever, just simply email Irene and she will be able either to answer directly or find out the answer for you. Okay, so I very strongly recommend that. Okay,